Hello, good morning, good afternoon, or good evening, wherever you are on this beautiful planet of ours. Welcome to Sustainability in Your Ear. This is the podcast conversation about accelerating the transition to a sustainable, carbon-neutral society, and I'm your host, Mitch Ratcliffe. Thank you for joining the conversation today. It's going to be an interesting one. It's also a new year, and this is the first episode of Season 5 of Sustainability in Your Ear. And believe it or not, this is our 499th show, and it's a pleasure to welcome you to 2025, which is going to be a pivotal year in the path to environmental recovery. It won't be an easy year for folks concerned about the deteriorating climate, but that cannot dissuade us from learning, sharing, and acting on the information that reduces our impact on the planet. And we're going to start this year with a dive into the world of biosolids. That's human waste, folks. A potentially transformative way to turn sewage that traditionally is seen as waste into a useful material for sustainable agriculture. With the appropriate precautions, humans can turn our ickiest stuff into useful fertilizer for farms and homes. In fact, people have been using their excrement as fertilizers for millennia. But at scale, biosolids-based fertilizer would be a big step towards comprehensive circular approaches to handling human waste. But it's a plan with challenges related to the presence of PFAS, the forever chemicals attracting growing concern as they're found in everyone's bodies only about 90 years after they were invented. We're joined today by Chris Piot. He is the Director of Resource Recovery at Bloom, and April Thompson, Senior Director of the program, which is operated by DC Water, the public utility responsible for providing drinking water and wastewater collection, as well as treatment services in the nation's capital. Chris is a pioneer in the field of water utility and biosolids management with decades of experience as a civil engineer. He led the development of Bloom, combining technology, science, and engineering to create a sustainable solution that is a fertilizer that's changing how we think about resource recovery and green energy. April has also been instrumental in shaping Bloom's products and overcoming the challenges of marketing something often misunderstood as icky waste as a benefit for anybody who buys it. Chris and April will discuss the science, innovation, and market dynamics behind Bloom. So let's jump into the biosolid story and explore why domestic waste may be a safer source of fertilizer than industrial waste. We'll get to the conversation in just one moment after this brief commercial break. Welcome to the show, April and Chris. How you doing today?
Great. Thanks for the opportunity.
Doing great.
Well, hey, Happy New Year. It's a pleasure to start the year off with you. You know, DC Bloom, you're making a biosolid product, in other words, a fertilizer made from a variety of waste, including human waste. How did the program get started? Chris, I want to ask you.
Sure. The wheels of progress turn slowly at DC Water sometimes. So this has been a very long process. My very first day of work was November of 1999, and the second day of work, I went to my first digester planning meeting. So we had a biosolids recycling program, but it was making a lime stabilized product. It was Class B by EPA standards, which means we can only use it in agriculture. And it was inconsistent. And we made a lot. Half of what got land applied in Virginia came from our plant. So we were having an effect on everybody. It was inconsistent from an odor standpoint. And we decided that we wanted to do something different. And we wanted something that was more sustainable, higher quality products, and something that would last for years, decades, a program. We wanted a program, not just a process. And I had come from the West Coast. I was a consultant in Seattle for a while, and I had worked a lot with Tacoma, Washington, and it's a much smaller plant than us. I'm sure we'll get into how big we are. We're huge. This is a much smaller plant that had digesters, and they were making a Class A digested biosolids product, different technology than us, and they were selling it to the public. And they would sell out every year in pre-sale. They would store it, and they would put something up, for sale, and people would buy it, and they'd sell out every year. And I remember in that first digester planning meeting, I raised my hand. I said, "Is there any reason that we couldn't do this just on a much larger scale?" So we used that as a template. And it chose equipment. We put in digesters, which we didn't have. Digesters, it's the digester's job to convert organic matter to methane, and then we reuse the methane to make green electricity, different things. And then out of the bottom of the digester comes the solids that can't be digested. It's very stable, low odor. We squeeze the water out of it, and that is That is our fresh bloom product. What's unique about our process, a lot of people have digesters, but what's unique about ours is we have preceding the digesters a process called thermal hydrolysis, THP, thermal hydrolysis process. It's a Norwegian technology. And ours was the first one in North America. It's the largest one in the world. But it was all over Europe. So we went over, sent teams over. I was on the first team to go over and try and vet the technology. And it's not like Europe is Jupiter with a different gravity or something. It's really, it's just the technology hadn't migrated over to North America, and we vetted it. We did pilot testing and found out that it makes a fantastic low odor, highly stable, nutrient-rich biosolids product. It's really, I think it's the most beautiful biosolids on the planet. I know it's my baby.
Well, let me ask that. Describe it. When I open it and I put my hand in, what am I going to feel?
Yeah, it comes off of our belts. We squeeze the water out with belts. We used to use centrifuges, which are really hard on the material. So we use these gentle belt filter presses to squeeze the water out, and it comes off and crumples up, and it just feels like moist and looks kind of like rich Iowa topsoil. It's dark brown, black. If you put it up to your face and smell it, you'll have a little bit of an ammonia bite, maybe a little bit of sulfur compounds coming off, but very, very little, much less than many compost products. It's very, very stable, and it's because we use that thermal hydrolysis process, which produces more gas, digests more of the volatile solids, and then leaves a very stable product coming out of the bottom. But it's about 32% solid, so it's like moist soil.
Yeah, I lived in Tacoma for about 40 years, so I know the
kidding.
product that you're describing. I remember that annual promotion that I would receive and am familiar with it. But a lot of people, when they think about human waste and the other waste that we process through a water treatment plant, they think just ick in general.
Oh yeah.
Well, I want to ask you, how do you present this to the public in a way that makes them both aware of the fact that this represents a circular process and that it's safe and healthy?
Yeah, I mean
Sure.
that's what we do. It is a circular process, and we're just really trying to complete that carbon and nutrient cycle. It's kind of the way the earth is supposed to work, right? We're not supposed to take our dookie and lock it into a landfill. We want to treat it to the point where it's an acceptable product.
Mhm.
And then, you don't just open your doors and say, come buy our feces product. We're very, very, very deliberate about promoting it. That's what April does. We have tours. We bring people in to show them. And whenever we say, would you like to buy biosolids? And then they ask, what is it? And we tell them, I could see the wheels turning. And I think that I imagine them envisioning us shoveling a bunch of turds into the back of a truck. That's not what happens at all. It's a process.
Absolutely. And we get mail about this from readers who say, I can't believe that these people are using human waste in fields and so forth in a variety of different contexts. So April, when you present this at retail or as an offer on the site, because you can download it or order it there too, how do you tell that story in a way that becomes attractive to the consumer?
There's an ick factor potentially, but there's also a cool factor. And I think there's a lot of folks who learn about this and are excited. And, we live in a city with a lot of environmentally minded folks who I think want to see recycling on a scale like this that often doesn't happen. I should add too that, Chris didn't mention this, but I mean, he mentioned we were the largest, but we're talking 450 tons of material every day coming off those belt presses. And so we do sell directly to consumers, but frankly, that's a small portion of what goes out. The lion's share goes to businesses, and that's everything from farms to golf courses to retailers that then go on and sell that to the consumer and to other, landscapers and so forth. So the it's a different value proposition for them. They want to know, does this fit my budget? Is it low odor? Is it going to be, is it going to work at the end of the day? And that's where we get, repeat customers again and again.
So you have several products. There's Fresh Bloom, which is the basic stuff, and then Woody Blend and Sandy Blend. What kind of growing is each of those designed to support, Chris? And who's using them?
Yeah, the fresh bloom is what we use on farms. We also sell that to soil blenders who are trying to make manufactured topsoil. It's sort of the foundation of a good manufactured topsoil. They'll add sand and different things to meet certain specs. Uh, and then on our website, we've got testimonials from horticulturalists and from farmers and from gardeners, all who use the product to grow vegetables, to grow flowers. The different blends are used for different things. April could probably talk a little bit more about what the blends are used for.
So the Woody Blend is kind of an all-purpose garden amendment. We tell folks that are used to using like a leaf compost that you can pretty
Mhm.
much substitute this. We do have a little more nitrogen, so it's kind of like the best of both worlds. You get the organic matter that you will get from a leaf compost, which does all
Right.
sorts of magic for your soil, but then you get slow release nitrogen and other micronutrients that your plants need. So that woody blend is often used in just amending, like a raised bed garden. People will also use it on their lawns, although the sandy blend is kind of our go-to recommendation for people growing turf. And that's everything from golf courses to, landscapers doing residential and commercial jobs. They can be used interchangeably, but we do have customers that just, in some cases prefer one over the other.
So how does Bloom, the product, compare to other fertilizers, both in terms of nutrient content and cost? Can you describe that, Chris? Is this a better deal and produce a better outcome?
Yeah, I mean, it's much more economical for the farmers to use our product than to buy ammonium nitrate fertilizer, for
Mhm.
instance. They would have to, if they're growing corn, they have to apply a certain number of pounds of nitrogen per acre, and they can either get that through chemical fertilizers or from us. What's good about our product is that not only does it have the nitrogen, but it also has micronutrients. It also has the carbon, which the ammonium nitrate does not have. So we're adding that, building the soil health by adding the carbon. And from a nitrogen value standpoint, we're selling it at, what is it, like 1/10 the price of ammonium nitrate, the nitrogen in ammonium nitrate. April can confirm that number, but it's in that ballpark. So it's much more economical for the farmers. It's part of the reason they like it. And they
Mhm.
get a lot more than they would get from conventional fertilizer.
Can a consumer buy Bloom directly, or do they have to go through a contractor? How would somebody get this if they were interested in following up on this conversation?
We do sell directly to consumers, but we also have a retailer network, including a company called Meadows Farms, which is one of the largest independent garden centers on the East Coast. So unfortunately, maybe for some of your listeners, we're only currently available in Maryland, DC, Virginia, and Pennsylvania.
Okay.
But they can go on our website. We have a dynamically generated retailer map. They can plug in their address and see where the closest retailer would be outside of getting it directly from us.
So what I want to, and much of the rest of the conversation, I want to talk about this in depth. A lot of people are concerned about this kind of material for basically lack of information, but also more recently, the rising awareness of PFAS, per and polyfluorinated materials that are known as forever chemicals. And they've been associated with cancer and so forth. I want to start off just by asking, what process does DC Water use to address the presence of PFAS, and how does Bloom ensure compliance with the existing safety standards that we have right now?
We're concerned about it as well. It is a ubiquitous forever chemical in our society. Sounds like you're pretty familiar with it. It's in consumer products. It's in household dust at about 10 times the concentration that is in Bloom.
Really?
Yeah, so our Bloom is a municipal biosolids, and there are cities who are impacted by industrial flow. DC does not have a lot of industry. I think only about 2 or 3% of our flow comes from industry. Most of it comes from residents and businesses. So we have what I call sort of background societal ambient levels of PFAS in the biosolids. It's there. We've been testing for years before it was ever required because we wanted to understand what was in the biosolids. We were sure that it was very low, but we wanted to confirm
Mhm.
that. So we've been testing for years, and we've been doing research trying to determine whether or not it makes its way down to groundwater. It does not at our levels. So it's extremely, extremely low levels. The average American has almost as much PFAS in their bloodstream as there is in bloom. And the concern has stemmed from some news articles that came out surrounding some farms in Maine. You may have heard.
Yes.
Farms in Maine. And, you know, unfortunately, the news articles didn't cover all of the facts. That was largely a farm that was contaminated with paper mill sludge that had, and paper is one of the consumer products that has lots of PFAS in it.
Yeah.
Especially food container paper. It can have thousands of times higher concentrations than what we have in our bloom. And, you know, the people in Maine were outraged that this farm had contaminated soils, and it was found in some of the wells underneath the farm. But that was probably in the order of 100,000 parts per billion of PFAS. And we're sitting at about 15 parts per billion.
Okay, so you make a really interesting point, and it actually applies to how we think about whether this can be scaled into other regions. It's the source that determines the level of contamination that you would have to address in the first place. And you make an interesting point about the fact that DC produces a lot of crap, but doesn't necessarily produce a lot of products. And I say that with a wry smile. But that raises the question, is this a technology that could be used in an environment where both industrial and household waste is being processed, or would those waste streams need to be separated in order to make the resulting products safer or applicable or useful in an environment like the farm?
Yeah, so nothing that we do at the plant removes PFAS. We are the solution for this is source control. So it's going out and monitoring industries. We have the only reason that we can have an EPA approved and certified biosolids reuse program is because we have an EPA certified industrial pretreatment program, which means that we have anybody who discharges into the sewer has to have a permit, and we go out and we do sampling, and sometimes it's clandestine sampling that they don't know about. And if we find that they are violating their discharge permits, we can cap their sewers, which essentially puts them out of business. So they take it very seriously. So we can do the same thing with PFAS. Our research department has gone out into the sewers almost literally and taken samples in all of the sort of industrial areas of DC and the residential areas. And we do not think that we have any high industrial dischargers. But if we find out that we do, we're going to then have to impose some limits on those. So the solution to it is source control. And really it's source control in the homes too, because most of the mass that is coming down to us, most of the mass of the PFAS comes from the residential areas because of the products that we use every day and end up in the sewers, everything from Teflon cooking pans to, you know, washing clothes in our laundry. And it comes down. Now, some states, Maine actually banned biosolids because of the intense public pressure, but other states have taken a more measured approach, such as Michigan, and then Maryland followed suit as well, where they made the distinction between industrially impacted biosolids and municipal biosolids. And then there's this tiered approach to monitoring and the limits. So if you're above a certain limit, you can't land apply at all. If you're between two numbers, you can apply at a certain rate. And if you're below a certain limit, you can land apply unlimited amounts, you know, up to the agronomic rate plants need. And Maryland followed suit and set limits in August, and we easily meet those limits. So.
And you apparently worked with Maryland as they were thinking through how to regulate this. Can you talk a little about that dialogue?
Yeah, sure. I mean, we pointed them in the direction of Michigan because we really didn't want them to do what Maine did because we thought it was supremely unscientific. Biosolids are sort of an easy target. It's poop, right? And it's easy to say we're just going to do this so that the public thinks that we're doing something about it, even though there are many more exposure pathways for PFAS in our society. But we didn't want Maryland to go down that path, so we pointed them in the direction of Michigan because Michigan had actually surveyed all of the wastewater treatment plants, got samples, and then set up this tiered limit approach. And Maryland followed suit, and other states are doing the same.
It's a great place to take a quick commercial break. We're going to be right back. Now let's get back to the conversation with Chris Piet. He is Director of Resource Recovery for DC Water's Bloom Biosolids program, and April Thompson, who's Senior Director of Bloom. DC Water sells Bloom, which is a fertilizer made from domestic sewage and converted into biosolids. And they report that Bloom contains significantly lower levels of PFAS. They're about 2,000 times lower than that found in consumer packaging. So I want to continue the conversation. And Chris, in particular, how does Bloom, when it's looking at the inputs to the process, ensure that the concentrations of PFAS and PFOS, and PFOA in the biosolids remain significantly lower than the material that you would get from an industrial facility like we were talking about? What do you do?
Well, we have, I think I mentioned earlier that we have an industrial pretreatment program. So we have them out sampling the sewers all throughout the sewer network to determine whether or not there is somebody who is maybe a new industry that is using PFAS that is now dumping it into the sewer.
Mm-hmm.
We haven't found that, but we continue to monitor because we want to know if somebody is dumping significant PFAS into the sewer at a point, because those point sources can be controlled. It's the type of thing that we can then say, you need to use something different, or you need to put in some sort of a treatment process to treat your relatively low flow, high concentration PFAS, rather than having it come down to the plant and having to treat the entire flow. We have not found any of those sources, but we continue to monitor.
The other thing I wanted to follow up on is we've spoken with organizations who are using epidemiological monitoring of sewage in order to understand public health. And we are going to measure everything eventually with various forms of sensors and networking and using AI. As we do that, do you imagine DC Water getting very granular about how it manages the inputs to the Bloom process? And is that something that would happen in the next decade, or is that Star Trek kind of science fiction?
No, it's not Star Trek at all. We were part of the epidemiological studies to look at tracing for COVID when COVID was happening. Our research department did sampling and we participated in all that. A little bit different for PFAS, because PFAS sampling is incredibly complex and you have to take really, really, really sort of intense measures to ensure that you don't get cross-contamination, because the analysis techniques can now get down to parts per billion, parts per trillion. And if you have somebody who has used the wrong kind of lotion in the lab and they did not put gloves on, it can contaminate it. So that type of sampling in the sewers is probably not in the next couple of years, but as sampling techniques increase, that is something that we would probably want to implement.
I'm wondering, April, how do you think about the need for transparency with regard to PFAS levels and Bloom and the concerns that people have, and educating them in response to, even a parts per billion kind of measurement sounds significant to a lot of folks. How do you get them to understand the really reduced risk and benefits of using poop?
Absolutely. I think we have been a little bit ahead of the curve with this. I early on was like, let's be proactive about educating consumers, because it is a really scary topic, but it's also really complex. I mean, we've just scratched the surface here. And a lot of times in the media, you're hearing, I mean, I used to be a journalist. It's like if it bleeds, it leads. And so, you're not hearing often these really nuanced conversations about PFAS and other contaminants of concern for that matter.
Yeah.
So we wanted to kind of like break it down and, just be really factual and get that information out first to our customers and the general public, and invite a dialogue on it. So we've had, and this particularly affects farmers. This is their livelihood, and you hear about it a lot more in the farm community. And we didn't want our customers not only to be concerned, but also to be potentially targeted for applying this on their fields. We did a whole event series, both virtually and in person, to kind of invite that dialogue. Chris, recently, we had him to speak at the Maryland Farm Bureau Convention. And, I think a lot of people, once they hear what we have to say, once they see the data, and we're happy to share, this is third party reporting that we are doing, by the way, not because we have been, required by the EPA, but because first and foremost, we wanted to have this information for ourselves. We don't want to be selling something that isn't safe.
One of the facts of life is that we now have PFAS in our environment. Understanding that we can reduce it and continue to reduce it in the output as we continue to eliminate the use of PFAS in products in the first place, which is an ongoing process. How do we help people understand that this is the safest way to do this? And are you exploring certification programs or working with certification authorities to bring some kind of seal of PFAS safe approval to market at some point? Have you thought about that?
I have not heard of such a actually I did buy some dental floss that
Mhm.
had a PFAS free kind of
Really?
thing on the label because dental floss actually has an extraordinary amount of PFAS. And of course, a lot of this is a moving target. Like, as I think these things are tested, and then a particular product kind of
Mhm.
gets targeted, in a good way by environmental groups to call this out. And we saw this with food packaging, where a few years ago it came to light just how egregious that this was in terms of the levels compared to many other things that, it makes sense. It's like, we want to keep the grease off our pants, as Chris likes to say, when we're, eating a Big Mac in your car or whatever. And so that led to a voluntary ban essentially
Mhm.
on that in the food packaging. And so I think we would love to be a part of any sort of voluntary certification that would allow consumers to get this information as they're making decisions. Again, it's a lot of these things are sort of secondary in the process, in the sense that it's not going to be something that you're going to see if you're looking on a label unless that is something required. And I think it's a good thing that more and more information is getting out there. We do participate in other certification. There is a bio-certified USDA certification
Mhm.
that we hold. And
Okay.
so I think those things are great for consumers. And Chris can probably jump in too.
Yeah, I just wanted to say, we do publish our results on our Bloom website. We hold these webinars all the time. We're very proactive about sharing the information because we want both the press and our consumers to understand how low the levels are in Bloom and how those concentrations sort of compare to products that we use every day. I like to use an analogy. April's heard me say it a million times, that like if a UFO came and hovered over my backyard and dropped a big pile of green goo in my backyard and then took off and didn't tell me anything about it, I would want it gone. It's like, I don't know anything about this. What is this stuff? Get it out of here. So we think it's an important part of the marketing to be very proactive so that people understand the risks.
Yeah, knowledge is power, and
Yeah,
and
yeah.
that's something that we have to. As I said, this is a fact of life. But if we can recognize where we are working to reduce the impact of PFAS, as well as use the material that has gone to waste, literally, for better outcomes, then we have a much better path to a sustainable society. Chris, let's change the subject a little bit. How does what you're doing with Bloom relate to your broader sustainability initiatives at DC Water? You're doing resource recovery and green energy, other projects. Tell us about how this all fits together into a broader umbrella strategy to make DC sustainable.
Yeah, thanks. So the mantra in our group, the resource recovery group, is there's no such thing as waste, only wasted resources. And
Mm.
I'm an engineer. It's my job to find all the underutilized assets throughout the organization and try and maximize them. So we designed this digester system with the idea that this was an asset that we had and not a
Mhm.
liability. It's our job at the wastewater treatment plant to remove the pollutants. I'm going to use air quotes, the pollutants from the water, and it's largely carbon and nutrients, a couple other things, but those are the things that are on our discharge permit because we don't want them ending up in the Chesapeake Bay and upsetting the delicate balance out there. But carbon is energy and nutrients are fertilizer. So we designed this whole thing not just for the bloom, but also the thermal hydrolysis system means we get more gas coming out of the top, clean up the gas, we burn it in a turbine and make clean, green, renewable energy, about 7 or 8 megawatts of power. It's enough to run a third of the entire treatment plant. We're the largest advanced wastewater treatment plant in the world, the biggest single site user of electricity in DC. So it saves us money, lowers our carbon footprint. And then maybe the coolest part of the whole project is that we could have put in an internal combustion engine to burn the gas, and we would have made maybe another megawatt of power. But IC engines don't run as hot as a turbine. Turbines, when they spin, they generate a lot of heat, and you have to shed that heat or you're going to melt your turbines. Most people will put a water jacket on it, dump the heat, but we need the heat. So we put heat recovery steam generators at the end of each of the 3 turbines, pull the heat off, make steam, and that's how we heat up the thermal hydrolysis process. So we don't need any external energy for that. We get renewable energy credits for the electricity and for the heat. And then that spurred us to look at other sources of heat. You're familiar with geothermal heating?
Oh, yeah.
Well, every city in America has geothermal energy flowing through its sewers. We've calculated that there's the thermal equivalent of about 200 megawatts of power running beneath our feet at any given time in the sewers, because we put BTUs in the water or in the sewers through our laundry and the dishwasher and the shower. And it comes into the sewer and it's insulated by the earth, and it comes down to the treatment plant, and those BTUs just pass out into the river.
Sure.
It's not great for the river, and B, it's a complete waste. So we're now harvesting heat out of the sewers and heating buildings. And it's an enormous opportunity for us to lower our carbon footprint.
It sounds to me like it is also the basis of paying for enhanced services at a number of different levels.
Absolutely.
Why aren't more cities doing this?
I don't know. I talk about it a lot at conferences. There are some that are doing it. It's not just us. Denver has a fantastic sewer heat recovery system, which makes sense because it's cold.
Vancouver, BC too.
Yeah, Vancouver as well. The whole Olympic Village was done that way. That was sort of our inspiration. But every city in the nation has this resource flowing beneath its feet, and the sewers can be used as a source of heat in the winter and a sink for the heat in the summertime. So it can be used all year round. And what we found, at least in DC, because DC has an aggressive renewable energy portfolio standard, and the utilities are required to have a certain percentage of their power come from renewable energy. And if they can't produce it themselves, they buy credits from somebody who is doing it. So we've certified all our equipment as renewable energy sources. We sell the renewable energy credits, which then allows us to have a pool of money to do more good work. So it's sort of this revenue cascade allowing me to build more solar and more different things.
I mean, in the long run, do you imagine that the city becomes self-sustaining and in a kind of a closed system sense? Can that happen?
I hesitate to say that we could provide all of the power and for all of the buildings, but I think
not necessarily for the city, for the industrial and commercial and residential use, but for the operation of the infrastructure of the water system and so forth.
Oh yeah, I've got a spreadsheet I've been working on for 10 years that shows that we can get to energy neutrality. If we put solar on top of everything, and we're slowly doing that, if we recover heat and we don't have to heat the buildings with gas or electricity, that yes, we can get there. And certifying everything as renewable energy sources so that we can monetize the RECs is allowing us to have money to do that, because there's all kinds of competing priorities, crumbling infrastructure, lead service lines that we need to replace and all that, all very important work. And what I'm proposing is discretionary. It doesn't have to be done, but it also makes us money and saves us money, generates revenue, and lowers our carbon footprint. So we have, again, another giant spreadsheet showing that we have a potential revenue cascade to do all this.
That's really interesting, and I'm really looking forward to hearing how that continues to evolve. Now, you've talked about the fact you make about 450 tons of this stuff a day.
Yep.
Is there any more capacity available? How are you going to continue to grow the balloon program in particular?
Yeah, so we also have a feasibility study to put in a receiving station for food waste. And I've got money in the budget. It's 10 years down the road. I'm hoping I can drag it a little bit closer to us. And we were smart enough to design our digesters with a space to put a receiving station. That's as far as we got. But that's another thing that DC is trying to divert, as many cities are trying to divert organic waste out of landfills, and they're looking for solutions. One of the solutions is to put up a giant composting facility. That's difficult to do because DC is densely populated, but we could be part of the solution. So that would then generate more green energy, more heat, and more biosolids. So we have the capacity to do it. We've got the feasibility studies done. We're angling to get some of these things done too.
So April, you're responsible for telling the story. How can folks follow along with what DC Water's Bloom program is doing, and maybe even buy some.
Absolutely. Well, they can go to our website, bloomsoil.com, sign up for our newsletter there. We are on Instagram at bloom.soil. You can reach out at bloom@bloomsoil.com, and we'd be happy to have you purchase or just follow on our story.
Well, it's a story that's full of crap in one way and at the same time in a good way. And I really thank you so much for explaining it to me. I know that everyone's going to be interested in following up. Chris, April, thanks for your time today.
Thank you. Really appreciate the opportunity.
Thanks, Mitch.
That was my conversation with two of the team behind Bloom, the biosolids fertilizer business launched by DC Water. Chris Piet, Director of Resource Recovery, and April Thompson, Senior Director of the program, were our guests today, and thank you for your time. You can learn more about Bloom products and the process that makes them at bloomsoil.com. Bloom Soil is all one word, no space, no dash, bloomsoil.com. Bloom and DC Water's path to becoming a self-sustaining, closed circular system that processes post-consumer wastewater to make fertilizer and capture heat to generate renewable energy should be an inspiration to cities across the country. Looking past the ick factor most of us associate with human waste and everything else that we flush down the sink and toilet, to see it as a resource and energy flow that can be reused will reorient our perspectives. We need to think like nature does, if nature thought like we do, to find ways to collect and use wasted materials and energy. Nothing in nature is wasted, but nature had billions of years to evolve species to fill every niche where life-supporting stuff was available, while humans have only decades to innovate processes and business models in response to the infrastructure we've already built to prevent further waste and the pollution it creates. As Chris pointed out, our sewers are an untapped source of value and energy that can be collected and reused instead of passing it into nature where it pollutes and warms the environment. A sewer is a man-made geothermal repository full of energy that we spent resources to generate but leave untapped once its initial use is completed. It's like we run our society as a body that after feeding one critical organ dumps any remaining nutrients and energy into the colon for disposal instead of passing the remaining value to other organs. To see this opportunity clearly, we need to continue to map and monitor our infrastructure. That's an evolutionary process that's proceeding quickly in the historical sense because sensor technology, AI that can integrate and present the information collected for human analysis, and new materials and processes are being invented all the time. Humans will always have a lot to learn and will always make mistakes along the way, like the creation of PFAS turning out to be a very bad idea in not even the long run. But we can avoid the fate of wasteful civilizations by recognizing the systems that we surround ourselves with can be more efficient when they're connected to siphon off value from the waste streams. So the circular economy makes tremendous financial sense if you look past today's bottom line. Stay tuned for more deep dives into the potential for resources to flow round and round on sustainability in your ear. And I hope you'll take a moment right now to share this podcast or any of the 499 interviews that we produced on sustainability in your ear with your friends, your family, your coworkers, the people you meet on the street. Folks, by writing a review on your favorite podcast platform, you help your neighbors find us. You are the amplifiers that can spread more ideas to create less waste. Please tell your friends, your family, all those folks I just mentioned that you can find us on Apple Podcasts, Spotify, iHeartRadio, Audible, or whatever purveyor of podcast goodness you prefer. Thank you for your support. I'm Mitch Ratcliffe. This is Sustainability in Your Ear, and we will be back with another innovator interview soon. In the meantime, folks, take care of yourself, take care of one another, and let's all take care of this beautiful planet of ours. Have a green day.